Hello learners and welcome to Programming for Beginners Part 1. This course is designed for people who are absolute beginners, having no coding or technical experience yet and want to start programming. Whether you are curious about how to build apps, websites, or just learn about how computers think, this course is the perfect place to start your programming journey. Get ready to learn, have fun, and unlock your potential as a coder. In this video, we're going to cover the very basics of programming and move on to advanced concepts step by step. Are you ready? Let's go! Now, why only this specific course? Well, you need no technical experience to start learning about programming. Next, it contains really essential concepts of programming. And it provides a really strong foundation and makes you think, visualize, and analyze like a programmer. And the best part, you don't need to learn any programming languages like Python, C++, Java, and others to learn the concepts in this course, as the lessons taught in this course are applied and are common to all programming languages. But before actually diving into the lessons, you have to understand some very important topics, which will be useful for the further lessons. So, starting with, are computers smart or dumb? What do you think? Well, computers are dumb and smart at the same time. And they can be smart as long as you give them proper instructions so that they can do whatever you want for you. Well, if you do not give proper instructions, your computer will not give whatever you need, and it will act something like a dumb computer. Alright, so what do computers understand? Well, here's one thing. Computers cannot understand English or any other human language. Computers understand a very special language called machine language or binary language. And what does this consist of? Well, this data consists of millions of zeros and ones, which we don't understand. So, unfortunately, we cannot type in this language. It is really difficult to understand the combinations of zeros and ones. Well, there are two types of languages that computers understand: high-level languages and low-level languages. Well, computers understand low-level languages like binary language or assembly language, which are really hard to type for humans. Well, and the next one, high-level languages, are something which humans can understand but computers cannot. Some examples of high-level languages are our human languages, everyday languages like English, German, Russian, Spanish, whatever. And all programming languages like Python, C++, JavaScript, HTML, all of these are high-level programming languages. The computer cannot understand them. But you might have seen people typing in these programming languages. But then how does the computer understand this? Well, there is a special software called a compiler which converts high-level to low-level languages for the computer to understand. Now, what is programming? Well, in the simplest words, programming is giving instructions to a computer or telling it what to do. We can ask a computer or instruct it to calculate something, build websites and apps, manage files, and ask it to handle data and analyze them using bar charts, graphs, pie charts, and many more. Now, some of you might have heard of the term coding, but do you know what that actually means? And is it the same as programming? Let us find out. Now, what is coding? Well, the act of writing instructions to a computer is coding. Well, when you give instructions to a computer, that is programming, but then when you actually type in the instructions, that is called coding. Well, these instructions are written through programming languages. Just as discussed earlier, Python, C++, Java, HTML are examples of programming languages, and these are used to give instructions to the computer. Well, remember, Coding is typing through hands and giving instructions to the computer. Now here is a very simple analogy to understand what programming and coding are. Say you want to make a new dish that you have never made before, but your friend knows how to do it and you want to ask him for help. Now, you have to follow your friend's commands exactly, right? That is how the cake turns out good. If you do not know what you're doing, the cake will turn out bad and the recipe would be ruined. So, the instruction your friend gives is just like telling computers what to do. In this case, computer is the one that wants to make the recipe for you and you have to tell it how to do it. Let's move on to the second part. How is code written? Let us see. Did you know how people in the 1900s and the 1800s write code and give instructions to computer? Well, they used special cards called punch cards that were fed into computers and the computer reads it, understands it, and then carries out those instructions. Here is how they look like. But now, because of the advancement of technology, code is written in IDEs or Integrated Development Environment that provide an interface for us to write code. Let us learn more about them in the next slide. Okay, then what are IDEs? IDEs are very special type of programs or software or apps that provides an environment for us to type instructions to the computer or code to the computer. Well, it has many useful tools that we can use to give instructions to the computer. Well, what type of tools? Well, you can use it to run the code, finding mistakes in it, organizing it, and many other tools. There are multiple IDEs out there like VS Code, Anaconda, PyCharm, Eclipse, NetBeans, and many more. Now that we have learned some very important concepts like how do computers understand and programming languages as well as compilers, how exactly do computers understand code? Well, let us see how that works. Now here is a computer. We give instructions by typing code in it. Now this code gets passed through a really special program called a compiler, which converts this code into binary language so that computers can easily understand this. Then, this is converted into the binary format and the computer reads it, processes it, and carries out the instructions you have given it. Now, let us understand how a computer compiles through an example. Let us say we want to convert this piece of text, hello, to make the computer understand what this means. Well, first we pass hello through a compiler, which converts it into the binary form which looks like this. This translates to hello, and the machine can easily understand this, but clearly I cannot. Now, the computer understands this, reads this line of text, and puts it on the screen for us to see. So, how do we even know what to code? Well, we type code through programming languages as discussed earlier. These are similar to our everyday human languages like English, German, or Russian. These coding languages have their own grammar or syntax. It's called syntax in programming terms. Well, just like we have our own grammar in English and other languages, these coding languages have syntax as well. Okay. Now what happens if we do not follow the grammar or syntax? Well, for our everyday languages, even if people make grammar mistakes, our human brains can understand it because of our ability to guess. Just like this man is saying, he's singing good. Even if he didn't say it in the correct grammatical form, this dude understands it and says, yes, he does sing well. But this is not the case for computers. Let us see. In a programming language, Python, this is a command used to display hello there on the screen. This is the correct line of code. But then, what if I spell print wrong and then miss a bracket at the end? the computer does not understand this and does not know what to carry out. So it throws an error, a syntax error. Now, what does this mean? This means that you have made a mistake in your instructions and there is a typo in your code. Now let us move on to part 3, variables and constants. It starts going a little uphill from here, but do not worry. We'll go through the basic concepts step by step in such a way that you'll understand everything clearly. What is a variable? Well, a variable is any value that can change or vary depending on the situation. A variable is an unknown value. It can be known, but then it won't have any specific value. Think of it as a box or a container. Its label stays the same or its name stays the same, but its contents can change. For example, a school cupboard. It is a box, of course, it is a type of box. One day it might have sports equipment, another day it might have notebooks, and another day it might have art supplies. Now, how do we define a variable in programming? Well, here is a simple string in a language called Python, and x here is the variable and 10 is the value. Now, I can give x different values like 10, high, true, or many other values like numbers, text, characters, strings, and many more, which we will learn further in this video. Here, x is given the value true. The value of x can be changed again and again how many times you desire it to change. Now, this process of giving a value to a variable is called defining, or more commonly, initialization of a variable. So here, x is initialized to its value. What is a constant? A constant is the opposite of the variable. Its value always stays the same and it never ever changes. For example, the number of days in a week is always 7 and this never changes. And the number of sides in a square is always 4. And many other examples are constants. Moving on to part 4, operators. This is a really important concept in programming, and computer carries out functions according to operators. So let us learn more about them in detail. What are operators? They are special symbols used in programming for computers to perform operations on numbers or values. Well, these are used in calculating, checking conditions, that means yes or no decisions, and logical reasoning. There are two main types of operators. The first type is unary operators. These symbols that perform an operation on a single number or a value. And next up, binary operators. These symbols perform on two numbers or two values. Let us learn more about them in detail. Now, the first type of unary operators is called the increment operator. Well, what does this do? It adds 1 to any number or value. The symbol for incrementation is two plus signs. Now, 6 incremented gives us 7, and 99, which is incremented, gives us 100. We're adding 1 to the number or the value, and the result is what we get after adding 1 to the value. So, for example, let us say you have 2 bars of chocolate, and if you increment it, we will add 1 to 2, which gives us 3 bars of chocolates. The second type of unary operator is the decrement operator. This is the opposite of the increment operator. This subtracts 1 from any number or value. This symbol for decrementation is a double minus sign. So, decremented 6 gives us 5 and decremented 99 gives us 98. For example, let us say you have 3 bars of chocolate and decrementing it, say you just ate one of them and you are left with 2 bars of chocolates. The third type of unary operator is the negation operator. Say we have a positive value. The negation operator turns this positive value into a negative value. For example, 5 turns into minus 5 on negation, or 99 turns into minus 99 on negation. Say you have a switch and turning it on means it is in its positive form. Now use negation on this value or positive value and the switch turns off. This off position of the switch is negative. So negation flips a positive value into a negative value. Now what are binary operators? Well, these operations work on 2 values or numbers. There are many types of binary operators, each of which we'll learn one by one. For example, 2 plus 3, 4 minus 2, 10 by 5, and 2 into 5. All of these operators like plus, minus, division, and multiplication work on 2 values or numbers. Now, let us learn the types of binary operators: arithmetic, relational, logical, and assignment operators, each of which have various purposes. Let's learn one by one in detail. Starting with the arithmetic operators. Well, these are used in computers for calculating simple mathematical problems like addition, subtraction, finding the remainder, and many others. Well, the basic 4 operations fall under this category. What are the basic 4 operators? Well, they are addition, subtraction, multiplication, and division, all of which are used in simple mathematics. There are 6 types of arithmetic operators. Out of these 6, 4 are the 4 basic operations like addition, subtraction, multiplication, and division, all of which are almost already known to everybody. So I'm not going to be going into detail about these 4. But there are 2 more types of arithmetic operators. The first one being modulus. This operator helps us find the remainder left over after division. Say you have 2 numbers. After dividing them, when they don't divide evenly, the modulus operator returns the remainder, or what is left after division. The symbol for modulus is a percent sign. For example, you have 7 cookies and you want to distribute it among 3 friends evenly. But 7 does not divide evenly by 3, or 7 is not divisible by 3. So what you do is each friend gets 2 cookies, but 1 cookie is left out. So after using the modulus operator on 7 and 3, you get 1 cookie, or 1 here is the remainder, what you get after dividing 7 and 3. Well, for example, in this Python computer program, we are asking the computer to print the result of 20 modulus 3. The output you get is 2. When you divide 20 by 3, it divides evenly by 6, and then 2 is left out, so that is the remainder. Let us look at the second type of binary operator, the relational operators. What are these even used for? These are special signs used to compare 2 values or expressions to find out how these 2 values are related to each other. They check whether one value is greater than, equal to, smaller than, or not equal to the other. Let us learn about each one of them in detail. Starting with the greater than operator. This checks whether one value is greater than the other. Its symbol is an angled bracket. For example, let us say we have a table of height 70 centimeters and another table of height 50 centimeters. Now, if you want to ask the computer whether 70 centimeters is greater than 50 centimeters, the computer says, yes, 70 is greater than 50. So the computer returns true. If not, the computer returns false for no. For example, here is a Python code snippet telling the computer to print the result of 20 greater than 14. Yes, of course, 20 is greater than 14, so the computer returns true. So the output is displayed as true. Next operator, the smaller than operator. This checks whether one value is smaller than the other. So the smaller than operator is the opposite of greater than operator. The symbol is an opposite angled bracket. Say you have a table of height 50 centimeters and another table of height 70 centimeters. After asking the computer whether 50 is smaller than 70, the computer returns yes, 50 centimeters is smaller than 70 centimeters. So the computer returns true, or else it returns false. Now here is a code snippet to print the result of 27 smaller than 35. Yes, 27 is smaller than 35, so the computer returns true. The equal to operator checks whether one value is equal to the other value or as same as the other value. The symbol for equal to is a double equal to sign. Say you have a table of height 50 centimeter and another table of height 50 centimeters, and after asking the computer whether 50 centimeters is equal to 50 centimeters, the computer says yes, 50 centimeters is the same as 50 centimeters, so it returns true, or else the computer returns false. Here is a Python code snippet asking the computer to print the result of 96 equals 96. Of course, both are equal, so the computer returns true. The not equal to operator is the opposite of equal to operator. It checks whether a value is not equal to or is not as same as the other value. For example, we have a table of height 70 centimeters and another table of height 50 centimeters. Ask the computer whether 70 centimeters is not the same as 50 centimeters. The computer says yes, both are not equal, so it returns true, or else it returns false. Here is a code snippet asking the computer to check whether 100 is not the same as 25. Yes, 100 is not equal to 25, so the computer returns true. So let us look at logical operators. These are special symbols that work with true or false or yes or no values to combine or change them. There are three types of logical operators: and, or, and not. Let us learn about each one of them step by step. Starting with the AND operator. This checks if both conditions are satisfied. It returns true only if both statements are true or yes, or else it returns false. Let us see an example to understand this better. Let's say you're going to a football match and you need 2 tickets, one for the seat and another for the food. You're only allowed to enter the match if you have both tickets. So, the computer returns true only if you have both the tickets or if both the conditions are yes. So do you have the match ticket? True. So do you have the food ticket? Also true. So the computer returns true. or yes, you can enter the match. Let us say we ask the computer to print 5 greater than 3 and 2 smaller than 4. Of course, both of these are true. So if both are true, the computer returns true because the AND operator is being used. So the output is true. The OR operator checks if any one condition is true. That means, let us say one condition is false and the other condition is true. So if one of them is false but the other one is true, it returns true. But if both are false or no, it returns false. Let us see an example to make this clearer. Let's say you have a door, okay? And then you have two buttons, the red button and the green button. So the door only opens when you press one of these buttons. But when you press none of these buttons, it won't open. So let us say we ask the computer to print 5 greater than 8 and 7 smaller than 10. 5 is not greater than 8, so it's false. Or 7 is, of course, smaller than 10, so it's true. One of these conditions is true, so the computer returns true. Moving on to the assignment operators. These are special symbols used to give, modify, or change the value stored in a variable. There are two types of assignment operators: basic assignment operators and compound assignment operators, both of which we are going to learn in detail. They store values in variables and they update, change, or modify them. Let us start with the basic assignment operator. The equal to sign is the basic assignment operator. This gives a value to a variable. Let us say we have a variable x. We're using the assignment operator or the equal to sign to give x the value of 5 here. So x is the variable on the left and 5 is the variable on the right. So the equal to sign gives x, or the variable on the left, to the value of 5, or the value to the right. Let us see the first type of compound assignment operators, the add and assign. This adds a number, any number or a value, to a variable's value. The symbol is a plus sign followed by an equal to sign. Let us say we have a variable x and its value is 5. Now, let us use the add and assign operator to add 3 to x. So it becomes x plus 3. We already know x's value. So x's value is 5 and we are adding 3 to it. So the value of x now becomes 8. We can change this because a variable can change or vary depending on the situation. The next compound assignment operator is the subtract and assign operator. This is the opposite of add and assign. It subtracts any number or value from a variable's value. The symbol is a minus sign followed by an equal to sign. Let us say we have a variable x and its value is 5. Now let us use the subtract and assign to take out 3 out of x. So now we are left with x minus 3. Remember, the value of x here is 5. So 5 minus 3 gives us 2. The next compound assignment operator is the multiply and assign operator. This multiplies any number or value to a variable's value. The symbol is an asterisk followed by an equal to sign. For example, we have a variable x and its value is 5. Let us use the multiply and assign operator to multiply 3 to x. X's value is 5 and 5 into 3 gives us 15. And one more compound assignment operator, the divide and assign. So this divides a value by a number. The symbol for this is a slash followed by an equal to sign. For example, we have a variable x and its value is 20. Now, let us use this operator to divide x by 4. Now the value of x is 20 and 20 by 4 gives us 5. So now x is 5. Moving on to part 5, data types. So what are data types? Now let's say there is a lot of information on Earth, depending on applications, files, data, numbers, and many more. So we need a way to sort these out evenly and neatly organize them so that it is easier to identify which belongs to what. So in simple terms, data types are containers that are made for specific types of things. For example, there is a container for numbers, another container for letters, and so on. The computer sorts all this data and organizes them so that it can easily identify which value belongs to what. Let us learn about the different types of data types in detail. Now, how many types of data are there? Well, there are 5 types of data, namely integers, float, characters, Boolean, and strings, each of which have different types of things. Now, how are data types useful? Well, they define what type of values can be stored. For example, each container has a different type of data. They support better analysis, and it keeps things neat and organized, or else it would just be a big clutter. You do not know what value is what. Moving on to the first type of data, the integers. Well, integers consists of only whole numbers. These have no fractions, no decimals, and no roots. So these are just plain whole numbers. These contain positive numbers, negative numbers, along with 0. These are used to count, index, or manage the amount of values in something. Let us say you have a basket of apples. We can use integers to count how many apples are there in this basket. In this case, there are 4 of them inside this basket. Moving on to floating point data type. Well, this has only numbers that have decimal points in them, or fractional values. These are not whole numbers. These can be positive or negative. These are used for precision, as they're more accurate than whole numbers. This means that decimal points help us identify more accurate pieces of information which whole numbers cannot identify. For example, taking an example of a kitchen beaker. This measures liquids in fractional amounts, not in whole numbers. It can be 0.5 pi. Pi's value is 3.14, minus 0.6789 or 2.15. There are many other types of decimal points. Next data type, characters. Anything enclosed within single quotes or double quotes and have only one element inside them are identified as characters. So characters are data type that holds a single letter, digit, or a symbol. It can be any one of these, but there should be only one element within the quotes. So this is used to represent letters and symbols inside the computer. That means this data type is used in computers to tell between letters, numbers, and symbols, especially on keyboards, where each key represents only one character. For example, take a word puzzle or a Scrabble tile. This has only one character inside it. Here, there's only A inside the tile. So this is mostly enclosed in double quotes or a single quote in programming. Some examples are the letter A, the symbol dollar, or the number 4. Notice that there's only one element within the quotes. Moving on to the last data type, strings. Anything enclosed within double quotes is counted as a string. A string differs from a character because it can store a sequence of letters, digits, or symbols. So it does not have one element in it, it has multiple of them. So here, the text hello is a string, and hello is a series of letters and a symbol. So this is enclosed in double quotes and is identified as a string. This is similar to a string of beads, where it is a sequence of any type of value. But there is one more data type, Boolean. These are the types that stores only two values, true or false. True is yes in our language and false is no in our language. This uses very little memory, and do you know what it's used for? It is used for making yes or no decisions. So it helps the computer to take decisions. Let us say you have a light bulb, and it can be only on or off. It cannot be anything between these two. On is true here, and off is false. Okay, moving on to the last part of this Part 1 course, Part 6, Arrays and Lists. Now, what is an array? Array is a row of containers where each container can hold only one type of data. Since we learned about data types, we know that only one type of data type can be stored in an array. The items in the array are lined up in a specific sequence or order. So arrays make it easier to organize and use values. The elements in an array are mostly closed in parentheses or round brackets. Let us see an example to understand arrays better. Let's say you're playing a game and you have 4 different scores, all of which are the same data type. So we can use arrays here because these 4 types of numbers are counted as integers, which are one type of data. So one of your primary actions is to store each of these values in 4 variables, namely score 1, score 2, score 3, and score 4. But instead of doing this and adding multiple variables and creating a huge mess, why not store all together in one array called scores? This makes it way easier to find out which one is scores without using 4 different variables. So you store different values in one container. So this is the better option as it saves time as well. And the best part, you can easily access the scores by using their order because they are arranged in a sequence. And this is an example of an array, 10, 20, and 30, which are enclosed in round brackets. So this is an array, and 10, 20, and 30 are the same data types, namely integers. So the output, print, as well, is used as a function to show something on the screen. So the computer displays 10, 20, and 30 on the screen. Now, what is a list? A list is a dynamic version of an array. Now, what does this mean? A list is just like an array, but it is more flexible than an array. The number of containers can change, so its size can also change. Arrays cannot change their size or their volume. Only lists can. A list can hold different types of data. It can hold numbers, words, and symbols, unlike arrays. So you can add and remove items anytime, as you can change their values. Elements in a list are mostly enclosed in square brackets, while arrays are enclosed in round brackets or parentheses. Let us see how lists are used through a simple example. Say we have a shopping list which has the different items which we have to purchase. Well, you can add and remove items here anytime. For example, if you change your mind and want to add one more product inside this shopping list, you can. So this makes it more flexible than arrays, as you can change its contents and its size can vary. Data here changes often because it's really easy to change the values inside a list. Now here is a table depicting the differences between a list and an array. Feel free to pause this video, take a screenshot, and use this as a reference. Congratulations! You have reached the end of this course and you have completed the essential building blocks of programming. I hope you understand all of these concepts in this course. In the next part, we'll explore more fascinating lessons, which I'm sure you will definitely wait for. So now you have built a very strong foundation for programming, as you have all the basic concepts in your head. Soon, let us add life to programming. This is it for this video on Programming Course for Beginners Part 1. Now, Part 2 is still in progress, but tell me what I should make next in the comments down below. Till then, it is your learning companion, LearnBlaze, signing out.